Thank you for being invited here today to give a short talk, which I have entitled, maybe a bit ambitiously, how to speeding up the cure for lung cancer. So, this is my challenge. This is my wife. She is now 32 years old. And 2 years ago, she was diagnosed with stage 4 EGFR positive lung cancer. This is my challenge, my love, and that's the reason why I'm here today. This is your challenge. This is the number of people who die from lung cancer in the world every year. 1.6 million people every year. And I thought I should do a brief status report, how we're doing in our war against lung cancer. So I had a look at clinicaltrials.gov, you know, this website where you can find clinical trials. There has been done more than 2,000 clinical trials in lung cancer. And these are only the trials listed on clinicaltrials.gov. I'm sure there are other trials in Japan and other places that are not listed. So more than 2,000 trials have been done. And what have we achieved so far? What has been achieved so far by these 2,000 trials? I don't know if you recognize this chart. It's maybe not so easy to see from the back, unfortunately. I think this is one of the saddest charts on Earth. If you don't recognize that, I'll show you now. This is the 5-year survival rate of stage 4 non-small cell lung cancer. It's around 2%, and it's been around 2% for 3 or 4 decades. We know that now, lately, there should be, hopefully, a small bend in this curve, but there's still a lot more that needs to be done. So why the failure? Why have we worked so hard for so many decades and still achieved some progress, but not so much progress as we would hope? And I'm sure there are many reasons and there are many views and why this has happened. But I just want to highlight 3 potential reasons that I think have been important. The first is, I think, an underappreciation of the heterogeneity that cancer is. Lung cancer in my wife is not the same as lung cancer in Lars' brother-in-law, as in other patients around the world. We know there is tremendous intra-patient heterogeneity. We also know that there is heterogeneity within the patient in different metastases and different types of cells and so on. We also know that within one tumor there is heterogeneity on different sites and different parts of the tumor. We also know that cells over time can develop and thus also introduce heterogeneity over time. There's just this vast amount of heterogeneity that if we want to cure cancer, we have to find a way to come around that. We have to take this into account when we design trials and try to beat this disease. Also, in my reading of the research on, in particular, EGFR mutated lung cancer, I still think we have holes in our understanding of the basic epidemiology, etiology, and development. We have learned a lot. There's been a lot of progress, but if you look at the up-to-date article on never smoker lung cancer, there's still basic questions. Is the incidence of never smoking lung cancer increasing or is it stable? This is still an unanswered question. There's no good data to find. There's still disagreement. Also on the etiology, why does EGFR mutant lung cancer happen? There's a tremendous disagreement and very few hard facts on this topic. And finally, I think there's also been a lack of vision and ambition, in particular among our leaders of our countries, our governments. They have many issues and problems on their plates, and unfortunately, solving lung cancer does not seem to be one of them. And I think that is unfortunate for the whole community, that there's just lack of vision and ambition to try to solve this from the top. And this affects funding and many other things. But I'm still hopeful. I'm here today because I'm hopeful. I think there is still tremendous reason to be optimistic that in the next years we can achieve much improvement. First of all, there has been, as you all know, recent great progress in EGFR mutant lung cancer and ALK translocated lung cancer. Now we have immunotherapy that seems to have promising results in smoking-induced lung cancer. And very importantly, we have new technologies on the types of treatment, local ablative treatments. We have minimally invasive surgery. We can do liquid biopsies. We can do CRISPR gene editing, we can do mass spectrometry, we can do next generation sequencing. We have so many new tools in our toolbox that I believe will help us to solve this and speed up the cure for lung cancer. And then in our journey the last 2 years, we have met tremendous people who really are amazing, extremely intelligent, extremely hardworking, dedicated, and the people we have met, I believe, are among the brightest people on this planet, and they are working to find a cure for this disease, and that makes me extremely optimistic. So, just a few words on how I think we can speed up progress. And I didn't mention initially, but I'm by training an engineer. And in engineering, there's a concept called reverse engineering. It's trying to imagine where you want to be and work backwards how to get there from this is where we need to be. So, if you imagine the reverse engineering solution to how to cure lung cancer, it will look something like this. What we want to achieve is 0 lung cancer deaths. This is our goal, 0 deaths from lung cancer. And we know that to achieve this, we need treatments. We need curative treatments, and we need these treatments to be approved by regulators, and we need these treatments to be part of the guidelines. And we know that the next step before that, again, is we need to do trials. We need to do trials to prove that these treatments work, are effective, and can be implemented in guidelines. And I think this is one of the areas where we have the greatest room for improvement today, the way we do trials and the way we manage trials. So I want to spend a few words on this. This is, in my view, trials today. This is a shot from the old Soviet Union, and this is a bit how I use trials today. First of all, for most patients, trials are simply not existent. If you went to try to find a shop in the old Soviet Union, there were basically very few shops. And the ones you could find, they were basically unattractive. They didn't have great fruit and vegetables and food and so on. There was basically a lack of things you could buy. And then, of course, we know from the economics that the trials or the shops, the economy in Eastern Europe was quite inefficient. And this is how I view trials today, and I'll speak a bit more on this. First of all, I think we need many, many more trials. Today there are roughly maybe 3% of cancer patients who join trials. 3% join trials. It's not easy to find data on this. This is more general for cancer, but I think it should be more or less the same for lung cancer. That's 97% of patients who never join a trial. And I think this is a double tragedy. It's first of all a tragedy for the patients themselves, because all these patients, we know, go on and die. And they never have the hope and the belief that maybe they can be cured or live longer if they join a trial. So that's the one tragedy. The second tragedy is that these people die in vain, because we as a community don't learn anything from these deaths, or we learn very little from these deaths. If these people had joined trials, we would learn more from what happened. And it's important to know that it's not an unwillingness from patients. There have been studies showing that 88% of patients who are asked if they want to join a trial say yes. So patients desperately need and want trials. So this is where I think we should be trying to head. Today, we had 3% trial participation rate. That means that every patient on average joins 0.03 trials. I think we should have an ambition and a goal to double this, to increase it by 100 times. I think every patient, every lung cancer patient can join 3 trials as part of their course of their disease. They can join 1 trial immediately when they are diagnosed. If there's progression, they can join another one, and if there's progression again, they can join a 3rd trial. I think we have potential here to 100 the number of trials we do. And I think if we do that, we will definitely speed up curing lung cancer. If we do 100 times as many trials, if we don't do 2,000 trials, if we do 200,000 trials, we will speed up this cure and finding this cure. Secondly, I think we also need to be more ambitious. I think most of the trials today often look like this. We take erlotinib, this is EGFR mutant lung cancer, which I know the best. We take erlotinib, we add one more thing. We know from all the great work done by Dr. Russell and many others in this room, there is an extraordinary amount of heterogeneity. We are unlikely to cure lung cancer, EGFR mutant lung cancer, with erlotinib and one more thing. Yes, we need to do these trials for safety. We probably need to prove that something is safe before we can add on more. But I think, in general, we need to think about trials that contain more interventions than just erlotinib and something else. This is how I would like to see a trial. If an investigator comes to me and says, Lars, this is the survival curve today, and this is the goal of our trial. Maybe this is too ambitious, but at least I think investigators should have as a goal that a significant amount of patients will be cured by this trial if it is successful. We clearly understand that it might not be successful. It is a risk in any trial, but I think the goal should be that if this trial is successful, a significant amount of patients will be cured. This is a trial that I would like to join, or my wife would like to join. And I just listed one trial. I'll not go through this in detail just in the interest of time, but I think there are ways we can do these trials. You can include many more interventions than you do today. Patients can accept and take it. And I think there are possibilities for doing this in a more aggressive manner than what we are doing today. Finally, we also need more efficient trials. Trials today are often quite small. They're costly to run. A lot of bureaucracy, a lot of red tape. They're not inclusive. A lot of patients are excluded from the trials. A lot of trials that we need and want to happen simply don't happen because there's not funding. There's not commercial interest in developing this compound for some reason or the other. And then, importantly, there's lots of biases and missing reporting from the trials. A lot of people are at fault here, and I think regulators need to take more care of this and make sure that when we do trials, at least we report the results we learn from this. What we need is inclusive, large, adaptive trials with many arms, and there is efforts in breast cancer, in squamous cell lung cancer, where they are doing this now and experimenting with new and different trial designs that enable us to do much more arms, more patients to learn more quickly. We definitely need a lot of funding from governments or foundations and so on, so we can do trials that include interventions that are not commercially relevant for some company to develop. And finally, we definitely need mandatory and rigorous reporting. So how? I just outlined what we can do, but the question is, of course, how can we do this? And I don't have, unfortunately, a solution for this. But what I believe very strongly is that when leading researchers and doctors and scientists work together with patients, there is an extreme amount of good things that can happen. We've seen it in the way that AIDS and HIV was cured effectively in 10 years. Extremely good work by patient advocates, extremely good work by scientists and doctors, and they did it in roughly 10 years. So, my wife, we need you to help her stay alive. And 1.6 million other people this year needs you to stay alive, and millions in the years to come. So let's work together. Let's try to be running even more trials, more ambitious trials, and finding ways to speed up the cure for lung cancer. Thank you.